Hey guys, welcome back to another edition of Algebra 2. Mr. Anderson here with you. We're in Chapter 8 now. We're in Chapter 8, Section 1, and we're going to talk about multiplying and dividing rational expressions. Okay, so let's get right to it. Our objectives for today, we're going to simplify rational expressions and simplify complex fractions. Okay, those are the couple of things we're going to be looking at. All right, so first of all, the first question that you might have is, what is a rational expression? Basically, a rational expression, as you can see here, is just a ratio. Look at this, a ratio, rational, maybe that's a way to remember it, of two polynomial expressions. So remember, we've talked about polynomials before, and it's just saying a rational expression is just that, some sort of a fraction. It could be a fraction like this, or down here where we've got different polynomials involved. Okay, so we want to simplify these. Think back to when we had, say for example, 8/12. What did we do? We can just simplify that fraction, and you might not remember how we do that, but remember, basically what we did here is we said, well, 8 is the same thing as 2 times 4, and 12 is the same thing as 3 times 4, and we said, hey, these 4's can cross each other out. They cancel each other out, and what we have left is the fraction of 2/3. So that's what we did when we were simplifying fractions. We're really doing the same thing. When we get into these rational expressions and we have all these polynomials, we're just seeing what can we cross out from the top and the bottom. Okay, if they have the same factor, in this case they had a 4 and a 4, if they have the same factor, we can cross that out on the top and the bottom, as long as they're being multiplied. Okay, so and you'll see as we go over a few of these things here, but basically in this next example here, we say, okay, I've got 3 times y times this whole parentheses. And then this whole parentheses here, y plus 7 times this other parentheses. So I cannot cross out this y here, the 3 and the y, this y right here. I can't cross that out with this y, for example, because this y is being added to 7. So I can't think of this y as being by itself. I have to think of it as the whole parentheses. The only way I can cross it out is if this whole parentheses, that whole y plus 7, can cross out, because it's being multiplied by another parentheses. And in this case we can, notice we have a y plus 7 on the top and a y plus 7 on the bottom. We can cross out that whole parentheses because that parentheses is being multiplied by 3 and y, and this y squared minus 9 is being multiplied by the y plus 7 on the bottom. So when we simplify this, we'd end up with 3y over y squared minus 9. Again, we cannot cancel that y with this y, because this is y squared, or y times y, but it's minus 9. We've got a minus 9 in there, and that 3 cannot cancel with that 9, again because of the minus sign in here. If this was y squared times 9, or 9y squared, yeah, we could cancel stuff, but that minus means I have to take that whole y squared minus 9 and cancel it, otherwise I can't do it. Okay, so that's kind of the one thing to remember there. Okay, next. Let's look at an example here. Okay, remember factoring? When we did factoring a little while back, we're going to have to do some factoring here. So you got to remember some of your factoring rules and some of the things that we did to factor. So in both of these cases here, we cannot just cancel out x squared and x squared. We can't cancel out these x's. Whoops. So there's only certain things that we can cancel out. Remember, they have to be all multiplied. Since we've got a minus and a plus in here, we have to factor these down to where we have something times something. This is another good use of factoring. All right, so remember, this is a trinomial. We're going to try to say, since there's no number in front of x squared, what times what is 3, but adds up to -4, and we say, oh, well, that's -3 and a -1. -3 times -1 is +3, but when we add them, we get a -4. So on the top, this will factor down to x minus 3 and x minus 1. Remember from when we did our factoring. On the bottom, what times what is 5, but adds up to be a negative 6. That's going to be negative 1 times a negative 5. So therefore, this is going to be x minus 1, x minus 5. Now notice, once we've got it factored down, now we've got a whole parentheses times another whole of parentheses. And same thing on the bottom. So now if you notice, they both have an x minus 1 in the parentheses, and those whole parentheses can cancel out, and we're left with x minus 3 over x minus 5. And that would be our answer. Okay? So if everything's multiplied together, you can cancel out top and bottom. But if you've got pluses or minuses in there, you're going to have to factor these down to get groups of things that are multiplied together. All right. Next. Whenever we have a fraction, which we do here, we're going to have some problems with certain numbers that cannot be used because we can't have 0 in the denominator of our fraction. And so we're going to go and simplify this just like we did on the last one, but then it also says for what value or values is the following undefined. Basically what this means is we can't have 0 in the bottom of our fraction. So we have to look to see what values of p would make 0 in the bottom, and we'll say p cannot equal those numbers. Okay, that's where it's undefined. All right, so let's factor these. I'm looking for two numbers that multiply to be a negative 3, but add up to 2. So that's going to be 3 and negative 1, right? So I've got p plus 3, p minus 1 on the top. On the bottom, two numbers that add up to be, or multiply to be negative 15, but add up to be negative 2. And if you think, 5 times 3, 1 would have to be negative, so it's going to be a negative 5 times a positive 3. When I add those, I get a negative 2. So p minus 5, p plus 3. And so now when you look at this, you go, well, is there anything that can cross out? P plus 3 and p plus 3, those are the ones that can cancel. So what I have left is p minus 1 over p minus 5. That's my answer. That's the simplified version of it. But also it says for what value is it undefined. Okay, even though these p plus 3 crossed out, don't look just at your final answer here. Look back at where you factored this. Let's look at this one here. What value of p would make that 0 on the bottom? If p was 5, then that would make it 0. So we'd say p cannot equal 5. Or that's what makes it undefined. And then also right here, if p was negative 3, that would make this 0. So p can also not equal a negative 3. So those are the two values that are undefined, or what p cannot equal, because we can't have that stuff happening. So 5 and negative 3, that's where it's undefined. Only on the bottom. Doesn't matter, you could get 0 on the top, that's totally fine, but just not on the bottom. Okay? Good. Another example here. Okay. Notice again, we do have a minus in both of these, so I cannot just automatically cancel out this a to the third and this a to the fourth, or that one and this one. I have to factor first. Now these are not trinomials, so I can't factor the way we were just doing. What kind of factoring can I do here? I can do G, C, F. Okay? Just penguins. Okay, I don't know why I just thought of that. All right, so we can take out a GCF. Okay, I'm sorry. I don't know why I thought of that. We can take out a GCF of what? A to the fourth. And so what's left here is B minus 2. On the bottom, what do these two have in common? They both have an a to the third. That's supposed to be a 3 there. And then what's left is 2 minus b. Now notice, we can do some stuff with the a's here, right? We can cancel it because now this is a to the fourth, or a times a times a times a, all multiplying times a parentheses, and on the bottom, a times a times a times a parentheses, all multiplying. So these we can cancel now in this form, and so those three a's will cancel three of these and leave me with still one a on the top. I'll do this in a couple of different steps here. And then we still have this rest of the stuff over left over. We got rid of some a's. Now if you notice, look at the parentheses here. They're not exactly the same, but they're close. You know, you got a b and a b and a 2 and a 2, but the minus and the pluses are wrong here. They're bad. Okay, they're opposite. Well, what happened? There was another time when we were doing like factoring by grouping, I think. If stuff didn't quite match up, what could we do? We'd take out another factor of a -1. So basically what I'm going to do is I'm going to take a GCF out of this top one of a -1. So I'm going to take out a -1. I still have my a there. And if I take out a -1, that's going to change these signs. And so it's going to be -b plus 2 or 2 minus b. And then you notice it will match up with this one on the bottom, and we can cancel, and all that's left then is -1 times a, or we could just say a -a. Okay, so sometimes keep in mind when you're factoring this down, if they're close but the signs are wrong, you can take out that -1, that factor of a -1, and then cancel those, and then you've got whatever you had times a -1. Okay? So penguins, penguins, penguins. Alright, so here on this screen we're talking about multiplying and dividing rational expressions. What we've done up to now is we've simplified them, but we're going to take it one step further now, and we're going to divide and multiply with them. All this is doing here in this little blurb, this is just reminding us how we add and subtract, or how we multiply and divide fractions. So remember, when we multiply, here under this one, when we multiply, you notice down here, we just take the two denominators and multiply them together. If it's b and d, we go b times d is bd. If you have a and c on top, a times c is ac. So it just means we multiply across the bottom, multiply across the top. And then when we're dividing, remember, like down here, when we're dividing, you take the second part and flip it. So you could either remember like multiply by the reciprocal, or I've also heard where they say flip the second guy, then multiply. So let's flip the second one, flip the second guy, then multiply. So instead of c over d, you make it d over c, and then you can just multiply across like we did up here. So b times c and a times d. So that's the two kind of things to remember when you're multiplying and dividing. Alright, so let's look at a few examples. In this case, the first one, we're multiplying. So really, all we have to do is we can think of this as just everything on the top we're going to multiply together. You could go 8 times 7, make it 56, 21 times 16, and make it whatever, and then kind of simplify from there. But what I would suggest is leave these as they are first, and then try to cancel what you can, and then multiply them together. So what I just think of this as basically one big fraction. So when we're multiplying, this is just all this stuff is on top, all this stuff is on the bottom, and we can just cancel out anything from the top with anything on the bottom because they are all being multiplied. There's no pluses or minuses in there. So just start canceling stuff out. Here's an x. That x will cancel out part of that and leave you with an x squared. The y's, here's a y squared. That'll cancel out and leave you with a y down here. 7 and 21. 7 will cancel out and leave you with 3 down here. And then here's 8 and 16, so that will cancel and leave you with 2 down here. So what ended up here, everything got canceled on the top. Remember, if there's nothing on the top, there's always a factor of 1. And then on the bottom, 3 times 2 is 6, and x squared and y. So that would be our final answer there. We cancel out everything we could. So just think of it as one big fraction, basically, and cancel anything on the top with anything on the bottom. All right, now, on the second one here, we have 10mk squared, 3c squared d. Now it's division, so we are going to flip it and turn it to multiplication. So now the 6c squared d squared will be on top, and the 5m to the fifth will be on the bottom. Now it's just like this one before here. It's one big multiplication. So just cancel anything you can on the top with anything on the bottom. No pluses or minuses. So let's look at here the 10 and the 5. That 5 can cancel and leave me with 2 up here. This m, and here's some m's on the bottom, so this m will totally cancel, and this will change that to an m to the fourth. There's a k squared. There's no other k's in here, so that's going to stay as it is. I got a 3 and a 6. That 3 will totally cancel and make that 6 2. There's a c squared and a c squared. Those will both totally cancel out. And there's a d and a d squared, so that d will cancel out, and this will become just a d. Now be real careful when you start canceling all this stuff out here. It's really easy to lose some stuff. In particular, at least the way I did it right now, this k squared could get lost in here. So if you want to, maybe you could go through and circle the things that you still have, and you notice I crossed everything else out. Or perhaps you want to like rewrite that k squared up high here so you don't lose it down in there. That'd be another way to go about it. But make sure, be real careful, because it's easy to lose stuff when you're canceling. So 2 times 2 now is 4, a k squared and a d, and then on the bottom m to the fourth. Oops, that went too fast there. So anyway, so we ended up with 4k squared d over m to the fourth. Okay, so flip the second one and then multiply, cancel top and bottom. All right. Now you knew it was coming. We got multiplication and division, but now we've got some polynomials where we do have pluses and minuses in here. So we're going to have to do some factoring. All right. So first of all, let's start out with this one. We've got 3 minus k, and on the bottom k plus 1. We're going to multiply it times now. K squared minus 1. We're going to have to do some factoring here. All right. Remember the different types of factoring that we've done. If there are two terms, we of course look for a GCF. But if there is no GCF, then we look for difference of squares. Well, first of all, is it a difference? Yep. It's subtraction. Is k squared a perfect square? K times k. And 1 would be 1 times 1. So if you remember that pattern, this would be k plus 1, k minus 1. Then on the bottom, kind of like what we did before, what times what is 3? But adds up to be -4, -3, and -1. So we're going to have k minus 3 and k minus 1. So we've factored this down. If you want to put these in parentheses here to make it feel nicer, you can do that. And then just cancel everything on the top and the bottom, whatever you can. K plus 1 will cancel k plus 1. Ooh, k minus 1 will cancel a k minus 1. Now look what's left. We have a 3 minus k and a k minus 3. Remember how we did this before with the -1 there? So let's take a factor of a -1 out of this top one, which is going to switch both of these signs. It's going to make it a -3 and a positive k. So in other words, k minus 3. And we have that k minus 3 on the bottom. So guess what? We can now cancel, and we're left with -1. Okay? So remember, whenever you get two terms that are the same except for both signs are different, then you can take out that -1 factor, and then they'll cancel. All right, division. Let's start by factoring here the 2d plus 6. We can take out a GCF of 2, and then we have d plus 3. On the bottom, trinomial. So we factor it like we did before. What times what is negative 2 but adds up to be 1? Well, that'll be 2 and negative 1. So this would factor down to be d plus 2, d minus 1. So we factored the first part down to this. Now remember, since it's division, we're going to switch it to multiplication and then flip these. That d plus 3 on the top will go down to the bottom. So we'll have a d plus 3 on the bottom. Then this trinomial will go up to the top and we'll have to factor that. So just like we did before, what times what is 2? But adds up to 3. That's going to be a positive 2 and a positive 1. So d plus 2, d plus 1. And now we just kind of cancel whatever we possibly can. Let's see, we got a d plus 2 and a d plus 2, a d plus 3 and a d plus 3. Notice what's left. We have a d minus 1 and a d plus 1. The 1 and the negative 1 are different, but the d's are the same, so we can't do our little negative 1 trick. We just have to leave this like it is. Don't forget this 2 out here. So you have 2 times d plus 1 all over d minus 1. And that would be our answer. Okay? All right, last one. Wow, look at that. This looks really crazy, but remember, it's a complex fraction. Complex fraction just means a fraction within a fraction. So basically what's going on here is this top part is a fraction on the top of a fraction, and this here is a fraction on the bottom of a fraction. And when we talk about fractions, what is a fraction really? A fraction is really just division. Okay? So here's what you can do. Just rewrite this. We've got x squared over 9x squared minus 4y squared, and then it's divided by x to the third over 2y minus 3x. So I just take this fraction and rewrite it as a division. So now I've got this top part divided by the bottom part. So you say, all right, that's division. Well, what do we do when we're dividing? Remember, flip the second guy, then multiply. So this now will become x squared over 9x squared minus 4y squared times 2y minus 3x over x to the third. We've turned it into multiplication. Okay? All right, now you go, well, I could start canceling a few things there. I see one thing I could do. But maybe there's something more I could factor. I can't do anything with x squared or x to the third or 2y minus 3x. But this one right here, the 9x squared minus 4y squared, we could factor that now. You think about, well, is there GCF there? No. But it's two terms. It's the difference, subtraction, and they're both perfect squares. So we could go ahead and factor this down. So this means that this would be 3x times 3x and 2y times 2y. And so this is the difference of squares. And so remember, the pattern goes 3x plus 2y, 3x minus 2y. And then on top we have x squared. And times 2y minus 3x over x to the third. All right, we're getting closer. So now you go, well, we've got it factored. Let's start canceling some stuff. I got this x squared, which could totally cancel. And cancel that and leave me with an x. And let's see, with what we've got left in here, remember this has to all be together. You go 3x plus 2y. Nothing quite matches exactly, but if you look closely, here's a positive 3x, negative 3x. Positive 2y, negative 2y. These two are the same thing, except for both signs are switched. So that's where we can pull our little negative 1 trick. So what I'm going to do is I'm going to take a little negative 1 out of here on the top. So I take out a negative 1. That means what do I have left is a positive 3x, because that switched, and then minus 2y. And then on the bottom, oh, don't forget this little x out here. I'll write that out in front. And you have 3x plus 2y, 3x minus 2y. And then last step is the 3x minus 2y's can cancel. And so what I'm left with is just a negative 1 on top, and on the bottom x times 3x plus 2y. Those two things. And that would be my final answer. So, so if you ever see a complex fraction, write it as a division problem, flip the second one, and then treat it, from that point on, it's just a multiplication problem. And you just cancel stuff top and bottom like we have always done. All right, thanks for joining me. That'll do it. Mr. Anderson signing off. We'll see you next time in section 8.2. Bye.